All right, how's it going today? We're Group 5, and I'll be presenting our Hickory Hill um, case introduction. So today our group is analyzing the Hickory Hill Smoked Food Company case. Hickory Hill's main issue was balancing inventory and transportation decision for its tendermost turkey product. The company had stockout problems in 2010, and so far 2011 it needed to find a better reorder point, a better order quantity, and the best transportation option. So our goal was not just to find the cheapest option, but the one that gives the best total logistics performance. So for question one, the selling price per case is $187.50 because each case has 25 pounds and the product sells for $7.50 per pound. Since 60% of sales revenue is directed variable cost, the cost of goods sold per case is $112.50. That leaves a contribution margin of $75 per case. This matters because every stockout on the product costs Hickory Hill's strong margin, not just sales volume. So for question two, projected 2011 revenue is 14 mil $448,000 after applying the 12% growth forecast. That converts to 77,056 cases for the year, or about 308.2 cases per business day. Using the order costs and carrying costs in the case, the EOQ comes out to about 911 cases. This gives Hickory Hill a cost-efficient order size, but still needs the right reorder point to avoid stockouts. So for question three, using the demand pattern in Exhibit 1, the standard deviation of sales is about 195.2 cases. This shows that the demand is not stable enough for Hickory Hill to rely only on average demand. The company needs safety stock because normal demand swings can still create stockouts. All right.
All right, I'll be going over question 4 and 5. For question 4, using the current 8-day lead time, the 3-day lead time standard deviation, and the demand variability from Exhibit 1, the safety stock needed for a 95% protection level is about 1,555 cases. That means Hickory Hill needs a much stronger buffer than it has been using. That likely results from fewer stockouts and better service, even though inventory carrying costs will rise somewhat. For question 5, if Hickory Hills raises service to 99%, it would need about 644 extra cases and about $13,000 more in annual carrying costs compared to 95%. If it lowers service to 90%, it could reduce inventory by about 343 cases and save about $6,947 a year. From a decision standpoint, 95% looks like the best balance because 99% may be too expensive, while 90% would likely make stockout problems worse.
All right, so I'm gonna go over questions 6 and 7. So for question 6, the reorder point are about 3,677 cases at 90% service, 4,020 cases at 95% service, and 4,664 cases at 99% service. This allows that higher service levels require the company to reorder earlier. In practice, that means that Hickory Hill needs to stop waiting too long before replenishing orders. And for number 7, the total annual logistics cost for the current rail option is about $585,094. Rail is the most expensive overall because the 8-day lead time increases the transit inventory and safety stock needs. Even if rail looks familiar and established, it creates more total system cost.
All right, so I am question 8, 9, and 10. Okay, so for question 8, the total annual logistics cost for common carriage trucking it's about $500,066.11. This is better than rail because the lead time drops from 8 days to 4 days, which reduces both safety stock and in-transit carrying cost. It is a solid improvement, but there is still some lead time variability. Now for question 9, the total annual logistics cost for dedicating trucking is about $562,000, which is the lowest of all three options. It's the biggest advantage, and it is guaranteed a 1-day lead time, which cuts inventory costs and improves replenishment speed. This also shows why transportation should be judged by total logistics cost and not freight rate alone. And lastly, for question 10, our recommendation is that Hickory Hill should use dedicated trucking for tender most. It has the lowest total annual logistics cost, the fastest lead time, and the best service performance. It should reduce stockouts, improve freshness, and make the system more responsive. The one caution is carrier dependence. So Hickory Hill should also think about backup plans and contract protections in case service issues happen later.
All right. Now that we finished all the questions, really what I can conclude that our analysis shows that Hickory Hill's biggest issue was not just transportation costs, but their interaction between demand variability, lead time, and inventory policy. So the company's existing approach left is exposed to stockouts because it was not carrying enough protection and inventory related to uncertainty in the system. By improving the reorder point and choosing a faster transportation mode, Hickory Hill can lower total logistics costs while also improving service. So our final recommendation is to use a 95% stock protection level as a balanced inventory policy and to switch to dedicated trucking for tender most. This combination gives the company a strong balance of cost control, customer service, and operation reliability.